In this video, we are going to learn about stress-strain diagram for ductile and brittle material. The relation between stress and strain is generally shown by plotting stress-strain diagram, where stress is plotted on vertical axis and strain on horizontal axis. Such diagrams are used for understanding behavior of material. Stress-strain diagrams are drawn for different loadings such as tensile stress-strain diagram, compressive stress-strain diagram, and shear stress-strain diagram. Stress-strain curve differ in shape for various materials such as ductile material and brittle materials. A material is said to be ductile if it elongates before fracture. One such material is mild steel. The shape of stress-strain diagram for mild steel is shown in figure, where mild steel is a specimen which is pulled until it breaks. The extension of mild steel bar are measured at every load increment. The stresses are calculated based on original cross-section area of mild steel bar, and strain is by dividing extension by gauge length. Where specimen of mild steel bar is loaded gradually in tension, the line of initial portion from O to P is linear, where strain linear varies with stress. This line is called line of proportionality and is known as proportionality limit, and the stress corresponding to this point is called as limit of proportionality. Here Hooke's law obeys in this part, and the slope of line gives modulus of elasticity. Further increase in load increases extension rapidly and stress-strain diagram becomes curved. At point Q, the material reaches its elastic limit, indicating end of elastic zone and entry into plastic zone. In most cases, P and Q coincide. If load is removed, the material returns to its original dimension. Beyond elastic limit, the material enters into plastic zone, and removal of load does not return the mild steel bar to its original dimensions, thus subjecting mild steel bar to permanent deformation. On further loading, the curve reaches point R, called as upper yield point, at which sudden extension takes place, which is known as ductile extension, where strain increases at constant stress by horizontal portion of diagram. The point R gives yield stress, beyond which the load decreases with increase in strain up to point R, known as lower yield point. After lower yield point has been crossed, the stress again starts increasing till the stress reaches maximum value at point S. The point S of stress-strain diagram is called ultimate stress. If the bar strain further, a local reduction in cross-section area occurs in gauge length, that is formation of neck. At this neck, the stress increases with decrease in area at constant load till failure takes place, and point T is called rupture point. The materials which shows very small elongation before they fracture are called brittle materials. The shape of curve for high carbon steel is shown in figure.